Hello everyone, welcome to the video. In this video, we are going to see the demonstration of a Tesla coil project. The Tesla coil circuit is connected to a 9-volt battery here, and this circuit that you see here is called a Slayer circuit. The Slayer circuit consists of a transistor. The transistor that we are using here is D883 NPN type transistor, and it has this tall structure that you see here is the Tesla coil. The Tesla coil is nothing but a transformer. It has a primary coil which you see at the base of the transformer. That is an insulated coil, while the copper coil that you see here is the secondary of the transformer. One end of the secondary coil is connected to this plastic globe which is covered with aluminum foil. So this is required to increase the stray capacitance of the circuit. So let's see the demonstration of the circuit now. When I press the switch here, the power is being transmitted to this Tesla coil. Now as I move a neon bulb close to this globe, you can see that it is glowing. This means that the power is transferred wirelessly from the globe to the neon bulb by wireless means. So this power transferred is in the form of AC oscillations, which is in the kilohertz range. The AC power transmitted is, we can determine the frequency of this oscillation by calculating the resonant frequency of this Tesla coil arrangement. The resonant frequency is given by the inductance and the stray capacitance of this circuit. There is a formula to calculate it, and I will be explaining it later. So the role of the transistor is to create these high frequency switching action. So that's how the circuit is working. That's how wireless power transfer works in general. Thank you for watching. This is a side view of the Tesla coil. Now let's see how the Tesla coil circuit is simulated in LTspice. So in this circuit, you can see that there is a 9-volt voltage source, which models the battery. Then there is a 22K resistor and an LED. Then we have a 2N2222 NPN type transistor. So this L1 is representing the primary side of the Tesla coil, and L2 is representing the secondary side of the Tesla coil. So we have chosen the inductance values in such a way as that the number of turns on the primary coil is 3 and the number of turns on the secondary coil is 1000. So this capacitance C1 is the stray capacitance of the coil with the aluminum coated globe, and this resistance is the resistance of the secondary of the Tesla coil. Let's now simulate this circuit. So the waveform that is loading in blue color is the voltage across the secondary of the coil. As I magnify the coil, let's find out what is the frequency. So you can see that the voltage across the coil has an amplitude of around 360 volts, and if we measure the time period of the oscillation, it comes out to be around 0.003 milliseconds. So if we convert this to frequency, we get around 333 kilohertz. Now let's see if this value matches with the calculation. So I have now got a resonant frequency calculator here. So the frequency of the oscillation at the secondary of the Tesla coil depends on the resonant frequency of the secondary side. So this is what is given in this website. So the formula for calculating the resonant frequency is 1 by 2 pi root of LC. L is the inductance of the secondary coil and C is the capacitance of the coil arrangement. So in LTspice, we have chosen the stray capacitance value to be 20 picofarad and the resistance value to be 10 megaohms. Then the inductance of the coil is 11.111 millihenries. So let's now input these values. 20 picofarads, 11.111 millihenry. So you can see that the resonant frequency for these values using the formula is 337.62 kilohertz. So this matches with the simulation that we made. One more thing that I would like to show you is the formula to calculate the stray capacitance. So I did a Google search on how to find the stray capacitance for the secondary side. So it is given by the this formula here. Total stray capacitance is given by capacitance of this aluminum foil covered sphere plus the capacitance of the winding. So for the sphere itself, the capacitance is given by 4 pi epsilon naught r. And for the secondary coil, there are different formulae. One formula that we can use is the Medhurst formula. Using this formula, the capacitance of the winding is given by K times D, where K is the coefficient given by height to diameter ratio of the coil, and D is the diameter of the coil. There is another formula to do this, and that formula is called the Knight's formula. So this is a better formula for calculating the capacitance of the Tesla coil. Typically, the value comes to around 10 picofarad to 30 picofarad. Thank you for watching this video about the Tesla coil project.